Hello guys, my name is Pino, and in this video we'll be going through question 4 from July 27, 2021, and for mathematics. Question paper, question 4.1, we are given the following three linear equations, and 4.1.1 we are to determine the determinant of coefficient expanding along the first column. So let's rewrite this without the variables. So there is 1 multiplied by a there, so we write 1 and the 2, the 3. So since we are determining the determinant of coefficient, so there is no need for us to include that 1, 3 and 5. We only have to include the coefficients of the variables. So we have 2, 3 and negative 2. We have negative 2, negative 3 and negative 1, which is multiplied by this c. So we are determining the determinant of coefficient expanding along the first column. So we'll be focusing on this column. So we sign, so we have plus, minus, plus, minus, plus, minus, plus, minus, plus. So if you forgot the arrangement of these signs, so just remember that the first one is always positive, and you cannot have a positive and a positive next to each other. So you can only get positive minus positive and positive minus positive. So you cannot have positive positive or minus minus or minus minus or positive positive. You always have positive minus positive, positive minus positive. So we have to determine the determinant of coefficient expanding along the first column. So let's pick that one first, and we block each and everything in its column and in its row. So we'll be left with 1 multiplied by the sign. So the first sign is equals to is positive. So we have 1 multiplied by, so since we are blocking the specified column and the row, so we'll be left with 3, negative 3, negative 2, negative 1. So now we come to the 2, and the 2 correspond with that negative, so we have negative 2. So when we block the associated row and the associated column, we'll be left with 2 and negative 3. So we are blocking that. So we are blocking that row and that column. So we are left with 2, 3, and this negative 1. And we have this negative 2 multiplied by that positive will be equals to negative 2. And so we are blocking that row and that column. So we are left with 2, 3, 3, and negative 2. So 3 multiplied by negative 1 minus negative 3 multiplied by negative 2 minus 2. 2 multiplied by negative 1 minus negative 3 multiplied by 3. We have negative 2. 2 multiplied by negative 2 minus 3 multiplied by 3. So this will be 3 multiplied by negative 1 will be equals to negative 3. Negative 3 multiplied by negative 2 will be equals to positive, but you have that negative as well. So this negative by that negative will be positive, and that positive multiplied by this negative will be positive, will be negative. So 2 multiplied by negative 1 will be equals to negative 2. This negative times that negative is positive. 3 multiplied by 3 is 9. So 2 multiplied by negative 2 is equals to negative 4. Minus 3 multiplied by 3, which is equals to 9. So let's use our calculator. So if 1 multiplied by negative 3 minus 6 minus 2 multiplied by negative 2 plus 9 minus 2 into negative 4 minus 9, and this will be equals to 3. So the coefficient of, so the determinant of coefficient will be equals to 3 when we expand along the first column. So even if we expanded along this first row, we were gonna get 3, or even if we expand across the second row, we get 3, or expanding also across along the last column will also yield 3. Question 4.1.2, we have to write down and evaluate the minor of negative 1. So let's write down the matrix with just the coefficient and without the variables. So we have 1, 2, 3, 2, 3, negative 2, negative 2, negative 3, and negative 1. So we are to write down the minor of negative 1. So we have the negative 1, so we block each and everything in its column and block each and everything in its row, such that we'll be left with 1, 2, 2, and 3. So 1 multiplied by 3 minus 2 multiplied by 2. So this will be equal to 3 minus 4, and 3 minus 4 is equal to negative 1. But let's indicate that we are looking for the minor of negative 1. So this will be equals to, the minor of negative 1 will be equals to that negative 1. Question 4.1.3, we have to write down and evaluate the cofactor of negative 3. So we have to also write our square of signs. So we start with positive minus positive minus positive minus positive minus positive, or if you don't want to use this, we can also use negative 1 raised to the power I plus j, where I and j correspond to the column number and the row number associated with negative 3, or we can use this square. So we are looking for cofactor. Unlike when we are looking with the minor, when you're looking for the cofactor, we have to use this negative 3 and multiply it with the corresponding sign. So negative 3 is here, so this sign corresponds with that negative 3. So we have to multiply this negative 3 by this sign. So if you're using this, you're also going to get negative. So this corresponds with this square of signs. So we have to cancel all the numbers associated with column associated with 3, and also the row associated with negative 3, such that we will be left with 1, 2, 3, and negative 2. So this is the cofactor of negative 3. So negative 3 multiplied by negative 1 will be equals to 3. 1 multiplied by negative 2 minus 3 multiplied by 2 multiplied by 3. One multiplied by negative 2 will be equals to negative 2. Negative 2 multiplied by 3 will be equals to negative 6. And 3 multiplied by negative 8 will be equals to negative 24. So this will be the cofactor of negative 3. Question 4.2, we are given the complex equation z is equals to negative 2 minus j multiplied by the square root of 6. 4.2.1, we have to write down the conjugate of z. So the conjugate is our complex equation, but we change the sign of the imaginary part, the j. So we have to change this sign of the j. So we have negative 2. So we have negative. So when we write the conjugate, we change the sign of the imaginary part j from negative to positive. So if it was positive, we are going to change it from positive to negative, but in this case it's negative, so we are changing it from negative to positive. J multiplied by the square root of 6. So this is our conjugate. So question 4.2.2, we have to determine the modulus of z and not of the conjugate, so our focus changes to that z. So the modulus of z will be equals to the square root of x squared plus y squared. Our x is equals to negative 2 squared plus our y is equals to negative the square root of 6 squared, and this will be equals to the square root of 10. So our modulus is our radius, and it's equals to the square root of 10. 4.2.3, we are to determine the argument of z and convert z to polar form. So the argument is the angle theta, which we can determine as theta is equals to arctan of y over x our y is equals to negative the square root of 6, and our x is equals to negative 2. So arctan of negative the square root of 6 divided by negative 2. So my calculator is in radians, so let me convert it to degrees. So when I convert it to degrees, so theta will be equals to 50,768. So we have to now convert z to polar form. So z will be equals to r cis theta, where we determined r, our modulus, as the square root of 10 multiplied by cos of 50,768. So the c stands for cos plus j, so the I stands for the j, and the S stands for sine of theta, which is equals to 50,768. So this will be equals to, so this will be our final answer, but you can just leave it as the square root of 10 cis 50,768. So